Good morning, everybody. My name is Jonathan Moses. I'm the District Geotechnical Engineer from PennDOT District 11. That's in the Bridgeville area of Allegheny County. Today I'm going to talk about some of our landslide remediation techniques, give you a few examples of some projects that we've done, also go over our geohazard inventory and rating, how we classify our different geohazards, including slides, and how we prioritize which one of those we work on. So just a little background here. Landslides are a result of numerous factors. Some of those include the steepness of the slope, the type of soil that's there. Human alteration is usually a big issue for us, and also change in moisture conditions. Fully saturated soil becomes buoyant, so it has less weight, less strength, and it's holding up a larger weight of material because the material above it is also heavier when it's saturated. So the result is that weaker material can't hold that up for too long, so it ends up failing and it reaches equilibrium typically lower down the slope. So the little picture on the right there kind of shows the hatching there, a superficial failure there of the soil. So some of the biggest triggers we see are the changing water conditions, like what we saw in 2018. We had very, very saturated soil for most of the year. We had superficial slides all over and some major landslides as well. Also the water content over time. We have a lot of clay-rich soils in this area. They can absorb moisture and soften due to that. Your landslides can move as a solid block of material, sliding on a weak layer. Can also move as like a thick oatmeal consistency of material moving down. Also, one of the things that we have in our area is what's called the Pittsburgh red beds. It's a layer of claystone that when it's exposed to the elements and deteriorates, turns into soil. It also is very slippery, so it acts as a lubricated plane for the material above it to slide down. Okay, here's just a couple different types of geohazards. Some of these are superficial, like you have a pipe failure here where the pipe separated for some reason or it rusted out. So then that started back scouring until the entire pipe washed away all up to the highway above. The top right here, what would be a normally stable slope becomes unstable due to the stream cutting into the toe of the slope over time to a point where it gets oversteepened and then it fails to reach equilibrium. The bottom right is sheet flow, so similar to stream scour, except the water's coming over the top, down between the road and the guide rail and just washes out the top of the slope until it becomes oversteepened, and then it fails to get to equilibrium again. And what we consider a true landslide on the bottom left there is more of a circular failure, where if you look at a cross section, it would be like a semicircle failure where all that material kind of fails and ends up going down towards the lower portion of the slope. Okay, PennDOT District 11 is 3 counties in western Pennsylvania. It is Allegheny, Beaver, and Lawrence counties. Just due to the different stratigraphy, most of our landslides are in Allegheny and Beaver. Lawrence is a different type of underlying conditions, so we don't really have too many there, whereas you have lots of mountainous and river environments here in the Pittsburgh and Beaver area, so that's where we see most of our action. So these were, at the time that I took this is all the different landslides that we were tracking. Here's our actual rating system. So you have the state route, the county road name, and there's 6 main factors that we use. One's the average daily traffic. Another is the cause of the geohazard. Another would be the length of the roadway that's impacted, the height of the failure, or the depth to a mine void if that's the cause. Also the roadway impact and the surrounding area impact. So I'll go over those a little more on the next slide, but basically we give a rating for each one of those on a base 3 scale and come up with your total geohazard rating. Then we can sort those on the highest one to the lowest, and the ones through a certain threshold are red, amber, and green, and that's kind of how we figure out which ones are the most important. Just because a particular road, might be failing and maybe even close to traffic, if it's a super low ADT, that might bump the rating down. So we tried to have a mix of rating categories to try to help us get a true picture of what's going on. Here you can see some of those thresholds and the values assigned for each one, like the average daily traffic, type of geohazard. Here you have simple things like maybe a rock fall or pipe erosion or sheet flow, which we don't consider really too big of a problem because it's not a true landslide, it's just a superficial failure, where you would have a creep failure, which would be a slow movement over time, or maybe an immediate collapse of the red bed layer, which would be considered a true landslide. You also have the length and the heights there. So basically these are all taken into account in our rating, and you have like low, medium, high, and that helps us to prioritize as a district which ones we're going to work on. We have multiple methods. We have an on-demand contractor who we can give sites to and they go out immediately. We also have our district maintenance crews who can go out and perform some smaller scale repairs. Other than that, we have to put the sites on the transportation improvement program, which is the TIP, and then try to get funds, and those are only allocated every so often throughout the year, and that TIP's updated every 2 years. So that's a longer term practice. So the ones that we feel need handled right away, we get to our maintenance guys or our maintenance contractor. So now I'm just going to go through a few case studies, if you will, of some of our repair techniques. There's many ways to repair a landslide, and some are more suited for each different type of application. This one here is State Route 2017, Blythedale Road. This is down in the Elizabeth area. So what happened here was a failure partially due to mine subsidence. So in our area, there's a lot of undermining of the Pittsburgh coal layer, and as such, those mines have sat empty for quite some time, and even during the war area, some of them were mined again to where they needed a certain percentage that were left in there, but during wartime said, hey, we got to take more out, so even more was taken out. So you have this periodic landslide, or not landslide, mine subsidence, in this case, caused the landslide. So on the left, we have one of our simplest, but yet most effective and cost-effective details where you excavate out the failed material, shown here as the dashed line, and then you bench in, bonding benches is what we would call these, bench in new rock. So you put in our rock, which is typically quarried, but you can also, sometimes we'll use borrowed material like broken concrete, or maybe some rock we have from another rock face that we've been cleaning up. So you can use that to rebuild the slope. On the right, it shows the mine grouting plan. Each one of those circles is where we were drilling to fill the mine. Typically, we use different types of concrete grout mixes, depending on what you have. If you hit a void, you have to have a low slump mix so that you have formed like a column. And once that column comes up to the hole in the above layer of rock, then you can fill that up. Some of it is mine gob. So when they mine, they push some material with equipment in to try to fill some of the void, but didn't fill it all. So you get like a lot of holes and voids between those rock particles. So that's a more slumpy material, kind of fill those voids. And then, sometimes you hit a column of coal, and obviously you would just fill that up to what you had drilled. So you try to, lay those out in a pattern that would give you the support you require underneath your roadway. So here are just some pictures of the completed. You can see all the rock embankment that was used to rebuild the slope. And then, obviously the mine is grouted in those locations that were shown on the previous sketch. Here's a failure that we had on Wildwood Road, State Route 4070 in the North Hills. You can see some of the failure types on the left there. What we have is a lot of roads have been stabilized by maintenance using gabions, which can be fine for a short-term fix, but a lot of times over time they settle because they are not rigid blocks. They are somewhat flexible, and then the road settles out as well. So one of the repairs that we did on this project was use of soil nails. So what they do with the soil nails is they drill those in the slope. They just drill a hole, and they place this nail in. These are just centralizers, so plastic pieces that just keep that nail in the center of the hole. Then they have little tubes which they grout, and the grout comes up and fills that. So if you're looking at a cross section, you see what a circular failure might be. Then you basically have these somewhat perpendicular to that plane to nail the front material to the back, but also provide that shear reinforcement to that slip plane. Here you can see the top of those nails. You have a nut on there, and then these spike plates. These spike plates hold the mesh tight to the surface, so you don't have superficial failures in between the nails. And then the nails obviously hold the front face of that slope to some of the rear material. Here's another example. This is State Route 3054, close to our office in Bridgeville. And what we did here was a geosynthetic reinforced soil slope. So there's a stream below here, so we were somewhat limited with how far we could go out laterally. So these GRS slopes work pretty well because you can stack them up to a 0.5 to 1 angle, where rock, usually we do a 1.5 to 1, or soil properly compacted is a 2 to 1 is the steepest you can go there. So this allows you to go to a 0.5 to 1, so you're stacking them a lot more vertical. And what these are layers of geogrid every 18 inches, and it's backfilled with suitable material. Typically we use number 8 stone, which is like a fine gravel because it's clean, but you can use any material that would pass the testing requirements. So here below is a profile showing you those layers and how they step up as the road grade steps up as well. And these are pretty cost effective. You excavate all the material and you place the geogrid and backfill and compact. You don't really need any large equipment other than an excavator and some trucks to haul and deliver material. This is showing we excavated down to the base of that particular repair. We're laying out the geogrid. We'll be backfilling after that. And here showing the finished product, you can see this facing in the front. It's filled with a little bit of soil behind it, 6 inches or so, to allow for just some growth to take place, but the main supports are underneath the roadway. The next one here is an interesting one. This is State Route 4063, Pierce Mill Road. This is in the North Hills as well. And what's going on is you have this large-scale failure, and you can see all the different levels. But down below, this is a landscaping that the private property owner had. So we couldn't really extend rock embankment or anything else far down the slope. We had to keep our repair closer up to the roadway. So what we did in this location was to install concrete caissons. So these caissons are drilled, and then they are filled with concrete. They also have reinforcing in there as well. These are not considered a wall. Walls are a structural element, and they have to perform as such, so they have a lot more strict requirements. As a slope treatment, you can have more deflection and more other things be allowed so that you don't have to have as much reinforcing in your column, and also you're relying on some of that slope to still be there. You assume a few feet down has failed, then you're still getting a buttressing effect towards the lower part. But what we're getting is our caissons were too large or too deep with the backfill, so we had to use lightweight, super lightweight backfill. It's a polystyrene geofoam product. So these squares are basically big blocks of styrofoam. Here you can see some of those. So you see the concrete caissons on the photo on the right there, and then everything was backfilled with these, and that was wrapped in a geomembrane. The unit weight of these are a couple pounds per cubic foot, where your typical soil compact is 120 pounds per cubic foot. So I have a little video here I'm going to attempt to show. Okay, yeah, I thought that was just a neat little video to share. That was something that consultant and the provider put together. Okay, the next example we have here is State Route 2001, Banola River Road, down again in the Elizabeth area. So what happened here was this was an old mining road with a coal mine a little bit down the road here. So at some point that mine was abandoned and the state took over ownership of this road. You have these old walls that were built roughly back in the 30s. The material has been, for reference, the Monongahela River is, a couple hundred feet down the slope. So material here has been falling and heading down towards the river for some time, slowly. So this wall has gotten undermined. So the wall basically just fell over because it didn't have any lateral support. So our solution here was to install soldier beam and lagging. This is, I don't want to say a last resort, but this is not one of our first choices just because it is a structure and it is expensive to install. So we didn't really have too many options here, and we needed a solid solution. There was a railroad below, so we couldn't really regrade this down to the river or anything like that. So this is kind of what we came up with. On the left, you can see the soldier piles. And on the right, kind of shows you we had some sections that were higher, so we had to anchor those back into competent rock. So that just shows you the anchors and how they're going back into the slope. You can see from these photos of the finished product that we do have whalers on this section of wall and the anchors anchoring those back into bedrock. Where the wall was lower, you can see that those sections were unanchored. So that's my presentation. So I appreciate your listening, and if you have any questions, you can ask those in the chat box.
Thanks, Jonathan. Yeah, I'll go ahead and Dr. I went ahead and asked a question about how deep the mine was beneath this SR 2017 landslide.
I think that was roughly 50 feet or so. A lot of times, rough rule of thumb is if it's 50 feet below a road or 100 feet below a structure, that's when we have issues. But that 50 to 60 range a lot of times is where we're seeing some of our issues.
And follow up to about, do you need to periodically torque the nuts on the soil nails and related to the Wildwood Road landslide?
No, I don't recall us ever doing that. I think we torque it to a couple kips, 4 kips or something, but it's a passive system. So it doesn't really have much resisting until that soil starts to settle and move a little bit. So that is a good question because it is a passive system. We're not trying to engage those soil nails all at once.
Yeah, and one more question before we move on. What are the environmental effects of placing the styrofoam? Is that something you guys take into account?
Yes, the only effects that I can think of is if there were an oil spill, if there's an accident above them, that gasoline could melt that styrofoam. So we do enclose it in a geomembrane and some stone around it. I can't remember if it's a couple feet or what, but we do try to block it off from any of those type of environmental effects. Otherwise, they're inert by themselves. So if they don't react with some other chemical, they're fine.